Shalom to you and welcome. In this video, we'll discuss inductive reasoning. There are two types of reasoning, so we'll see what inductive type of reasoning is and then use it to make conjecture, which means that to predict what's going to happen in the future if a pattern continues. So a conjecture is an educated guess, or an unproven statement based on observation. So you observe a pattern and then we can make conclusion based on that pattern. So inductive reasoning is the process of using that observed pattern to make conjecture, which is the conclusion. So how many dots would be in the next pattern? Explain. So we observe the pattern first and see what happened. Again, for it to work, for conjecture to be true, it has to work for every one of them. It will not work for some. Even if one of them is missing out, then it will not work. So we look at the first pattern. We have one. Let's label them. This is the first one that happened, and this is the second one. This is the third. This is the fourth. This is the fifth. Okay, so they want us to, what will happen in the next? The next will be the sixth. Okay, so we see in the first pattern, it has 1 and it has 1 dot. Okay, let's see what changed. When we move on to 2, so there are 3 dots, but how is that related to the former one? We have 1, what we had in the past, and then we had the number 2. So this had 1 plus 0 plus nothing, which is 1. So this had, the step 2 has 2 dots at the bottom plus the 1 from the previous add-on. So that gives a total of 3. Come to the step 3, has 3 dots at the bottom, and then it added on the 3 from the previous, so they're making it 6. Step 4 has 4 dots at the bottom, and then added on the 6. Okay, you can see. Again, I can just circle the one added on, you can see. So then added on the 6 dots from the previous plus the 4 at the bottom. Fifth one, again, has 5 dots at the bottom, and then it added on 10 from the previous, so making it 15. So now we can see this pattern goes for all of them. So what will be in the sixth one? So the sixth is going to have 6 dots at the bottom. 1, 2, 3, 4, 5, 6. And then it's going to add on the 15 from here. So we're going to have 15 plus 6 to get how many dots that will be in the next one. That will be 21. Okay, so that is it. So by observing this pattern, we have made a conjecture that there will be 21 dots in the next if this pattern continues. And with that, we can find the next. If I ask you, how many dots will be in the next one? That will be, the next one will be step 7. That will be 7 plus 21, which will be 28, and so forth. Okay? So observing pattern is very helpful, and math is all about pattern. So open our eyes and see it. So now, counter example is, counter means the opposite. Counter example is an example that shows that a conjecture is false. Sometimes a conjecture may be true, conjecture may be false. So we have to look at it, and that's why we have to evaluate it. So somebody make a statement, said the sum of 2 composite numbers must be a composite number. So what is a composite number, by the way? A composite number, if we take out all the prime number is any number that does not have only itself and, 1 as the divisor, no other number goes into them. So prime numbers would be, or some of them, will be 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. So if it's saying that the sum of any number that is not prime is composite. So a number can be either prime or composite. So which means any number that have other divisors, at least one divisor, it's a composite number. So that this statement, the sum of it, if they're asking us to provide a counter example, that means the statement must be false. If the statement is true, then there will be no counter example. So for there to be a counter example, it means the statement is false. So if it is false, find a counter example to prove that it is false. So if we can find any two composite number we can add and get a prime number, then that would be a counter example. Okay, I can think of one quickly now. I know 10 is a composite number because 2 goes into 10, 5 goes into 10, and so forth. So 2 plus, because since it says the sum, we have to add it. So 9 is also a composite number because 3 goes into 9. So 10 plus 9 equals 19. And we see 19 is a prime because there's no other number that goes into 19 except 19 and 1. So we can see this is a counterexample because we have found two composite numbers we added and get a prime number. So there are some others also. For example, if we add 15 plus 8, 15 is a composite number because 3 goes into it, 5 goes into it, and 8 is a composite number before 2 go into it, 4 goes into it. So, but if we add two of them, we're going to get 23. And 23 is a prime, you see. So that's another counterexample. All right. So again, to prove that something is false, we have to provide a counterexample. So for a conjecture to be true, it must apply to all items in the pattern. Like I showed with the dot, all of them, they have to apply. Not just the first few items, all of it. Okay. Show that the sum of the interior angles of a polygon with n sides is 180 times n minus 2. So again, we have to show that for all these figures we have here at least. So this polygon starts with triangle. So let's add on the triangle. Triangle has 3 sides. So this will be 1, the first polygon, second polygon, third polygon, fourth polygon, fifth polygon, sixth polygon, and so forth. So, and since we know the sum of angles in one triangle is 180, so triangle is the first to start with. So the sum of this is going to be 180. Okay, so yeah, this is triangle. Since we name all of them. Okay, so how many sides? Triangle has 3 sides. Sides will be 3. Side for quadrilateral will be 4. Side for pentagon will be 5. Side for hexagon will be 6, 7, 8, and so forth. So we can see the pattern. The first polygon, which is a triangle, has 3 sides. And then, how many triangles can we get from it? Just one triangle, which will be 180. So, number of triangles. Number of triangles is 1. Okay, and then the number of triangles we get for the quadrilateral is 2. And we can see those number of triangles corresponds with their number according to the number of the polygons. So this will be 3 triangles, 4 triangles, 5 triangles, 6 triangles. And we want it to match with the sum, because if there's one triangle, then it's 180. So it's 180 times 1. 180 times 1. So if it has triangle has it has 3 sides. So 3 minus 2 would give us 1. So we have the 3 minus 2 will give us the 1. So because it takes 3 sides to create a triangle, to create one triangle. So, and this will be 4 sides minus, that's 4 minus 2 give us 2. And 5 sides minus 2 will give us 3. No, so I don't want it to be messy. I'll just leave this under the numbers we are getting. I will just make it like this. Okay, this is 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So 7 minus 2 is 5. 8 minus 2 is 6. So we can connect, since the numbers of the triangle corresponds with the number of the polygons. We have first polygon, second polygon, so it's easy to, and then the number of sides that polygon have. So this is the number of side the polygon have minus 2. So the number of side minus 2, 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 the number of side minus 2. So if we know how many sides that polygon is, we take away 2, that will give us how many triangles there are. Therefore, if we know n sides and we subtract 2, that will give us the number of triangles we are going to get there. And that number of triangles we multiply. Since one triangle will give us 180 degrees, the sum of their angles, if we add up all the three angles in it, give us 180. So if one triangle will give us 180, then we take, to find any number of polygon angles a polygon would have, we can multiply it by how many sides that triangle minus 2 that have. Okay, so therefore that's why we can multiply that by 180, and that gives us the number they want us to, expression they want us to prove. So with this we can find, so you're finding area of one triangle times how many triangles there would be there. Here there are 2 triangles, so this would be 180 plus 180, because each triangle would have 3 angles in them together. Okay, hope that makes sense. So with this we have proved that the sum interior angles of a triangle would always be 180 times the quantity, the number of sides minus 2.